Hello, my name is Antim Gupta and my registration number is 16BME1163. So today I'm going to discuss on Rankine cycle. So this is a diagram of Rankine cycle. It has main basic component boiler, turbine, condenser, pump. So Rankine cycle is a vapor power cycle. It means a vapor is being used to get work done in the turbine. So generally it is a steam, means the vapor form of water is being taken from for doing this work. We can see in Rankine cycle there are four basic components. Once again, boiler, turbine, condenser, pump. So let us start from boiler. In the boiler, the liquid water is being fed. This is the boiler. Liquid water is being fed. Then heat is supplied to this liquid water. Heat. So what happens? The water then converts into high pressure steam, that is superheated steam. By the formation of steam, the enthalpy of water increases. The steam then generates from here. Then the steam hits the blade of the turbine. This high velocity steam strikes the blade of the turbine, so it rotates the turbine shaft, and in turn turbine shaft is connected to a generator which converts mechanical energy to electrical energy, and the rest over water is again being transferred to condenser, and then the condenser the water in the condenser loses the heat, so the water then again is being pumped back to the boiler. So this whole process keeps on going. This cycle is Rankine cycle. So it is a device, or we can say cycle, which converts steam to work. So here is something about Rankine cycle. Rankine cycle is a cycle that converts heat into work. The heat is supplied externally to closed loop. The cycle generates about 90% of all electric power used throughout the world. The Rankine cycle is a fundamental thermodynamic underpinning of the steam engine and thermal power plant. So this is the diagram of Rankine cycle. This is a condenser, turbine, boiler. So it contains four processes in TS diagram. So first is isentropic compression in pump from 1 to constant pressure heat addition in the boiler 2 to 3, isentropic expansion in a turbine 3 to 4, constant pressure heat rejection in a condenser 4 to 1. Let us suppose the outlet of turbine is S2, and when water is fed into container, suppose heat loss is Q2. So this is Q2. So coming from condenser, the S3 will be less than S2 because amount of heat is being lost by steam. The pump is taking this liquid water and then forcing it to boiler. Since pump is doing some work, so the enthalpy of water will increase, because in the case of pump, the work is being done on water, and in the case of condenser, heat is lost, so the enthalpy will decrease. Similarly, the enthalpy at the turbine inlet, which is S2, is greater than the enthalpy of turbine outlet, which is S2. So work done is S1 minus S2. Here Q2 is S2 minus S3, and the work is done by the pump. So here the work done is H4 minus H3. So the enthalpy of will increase, and same with the boiler, H1 minus H4. So here is a small video which will clear all our doubts about Rankine cycle.
The hot water enters each power generation unit. In this binary system, the well water does not come in contact with the turbine, but rather its heat is transferred to a secondary working fluid as it passes through the coils in the heat exchange tank. Because the working fluid has a boiling point much lower than water, the fluid flashes to vapor quickly. and moves upward, passing through the turbine. Pressure from the vapor spins the turbines, which in turn spins the electric generator. Each unit can generate about 280 kilowatts of power. After leaving the turbine, the vapor moves upward into the condenser tank. Here, cooling water enters the condenser from the cooling towers and circulates through coils in the condenser tank and cools the vapor, allowing it to condense back into a fluid The working fluid now flows down the tank outlet to the pump, where it is repressurized and injected back into the heat exchange tank to repeat the process. It is important to note that the three fluid systems of hot well water, cooling water from the cooling tower, and system working fluid remain in their own separate loops and never mix, so there is no contamination and no emissions.